They are some of the strangest and most intriguing rocks in our solar system. They are not quite asteroids and not quite comets, but something oddly suspended between the two categories, defying the labels that astronomers have relied on for decades. These unusual bodies have been given the name dark comets, a term that reflects both their mysterious nature and the puzzling characteristics that set them apart from anything we previously understood. Scientists studying these objects admit that no one is entirely sure what to make of them. They appear to represent an entirely new class of celestial body, one that might hold answers to some of the most profound questions in planetary science, such as how Earth first obtained its water. At the same time, they may also represent a subtle, but previously unrecognized threat to our planet, one that humanity has only just begun to appreciate. As unusual as they are, we now have a rare opportunity to learn more about these enigmatic objects, thanks to a Japanese spacecraft that is, by coincidence, already on its way toward one. When it reaches its target in 2031, we may finally discover what dark comets truly are, how they behave, and what their existence means for our understanding of the solar system. The story of dark comets begins in 2016, when astronomers detected an object that seemed to be an asteroid, but behaved suspiciously like a comet. Traditionally, asteroids and comets have belonged to two very distinct families. Asteroids are primarily rocky, inactive bodies that orbit the Sun, often clustering within the asteroid belt between Mars and Jupiter. Comets, on the other hand, are icy bodies originating from the cold outer reaches of the solar system. As they approach the Sun, their ice vaporizes, releasing gas and dust that form a glowing coma and long tails stretching across millions of miles. These visual signatures make comets difficult to mistake. Yet the object discovered in 2016 blurred the line between these two categories in a way that no one expected. Observations showed that the object's orbit received a subtle but definite boost from something other than gravity. Although the acceleration was tiny, fractions of a meter per second, it was noticeable enough to be detected by telescopes tracking its motion. This type of non-gravitational acceleration is typical for comets, whose jets of vaporized ice create a small but measurable push. But in this case, there were no visible tails, no glowing coma, no sign of dust or gas escaping from the surface. The object appeared inert, as silent and dead as a rock, yet it acted like something very much alive. The mystery deepened in 2017 when another strange object appeared, one that captivated both the scientific community and the public. This was the elongated, cigar-shaped body known as Oumuamua. Roughly 115 to 400 meters long, Oumuamua looked nothing like a traditional comet or asteroid. It exhibited an unusual tumbling motion, changed its speed in ways that could not be fully explained by gravity alone, and lacked any detectable tail or dust cloud. Scientists eventually determined that Oumuamua was likely an interstellar object, the first known visitor from beyond our solar system to pass so close to Earth. Its brief appearance and even briefer stay, slingshotting around the Sun before disappearing back into deep interstellar space, left behind more questions than answers. Astronomers debated whether it was an exotic type of comet whose outgassing was simply invisible to our instruments, or whether it was something entirely different. Regardless of the interpretation, it demonstrated that objects capable of exhibiting comet-like acceleration without visible comet-like features were not merely theoretical curiosities. Then, in 2023, a breakthrough occurred. A team of astronomers, led by Darryl Seligman at Michigan State University, announced the discovery of 6 more objects within our own solar system behaving in this same peculiar way. These bodies, all between 4 and 32 meters across, followed asteroid-like orbits near the Sun, but exhibited bursts of acceleration that could not be attributed solely to gravitational forces. Although the acceleration was minuscule, on the order of 1 nanometer per second, it was enough to nudge their orbits by hundreds of kilometers over the span of a few years. That kind of drift may seem insignificant on human timescales, but in the vast vacuum of space, even such small changes can accumulate into major deviations. What made these discoveries even more compelling was that all of these newly identified dark comets lacked cometary tails, just like the earlier objects. They gave off no obvious clouds of dust or gas, no reflective signatures, and no hint of icy jets, yet something was clearly altering their trajectories. At nearly the same time, another important clue emerged. Seligman and his colleagues published research showing that a near-Earth asteroid called 2003RM, measuring around 300 meters in width, also behaved like a dark comet. Despite its asteroid-like appearance, it too experienced mysterious accelerations. The discovery was unsettling because near-Earth objects already command attention due to the potential danger they pose if their orbits intersect with Earth's. If 2003 RM, and possibly many others, are undergoing subtle, unpredictable changes in motion, then our long-term models of their trajectories may be incomplete. The ability to forecast potential impacts depends heavily on accurate orbital predictions. If an object is quietly drifting due to hidden forces or processes, the uncertainty in its position increases over time, potentially complicating impact risk assessments. This raises one of the biggest unknowns surrounding dark comets. What exactly causes their invisible thrust? Several hypotheses have been proposed, each with intriguing implications. One possibility is that dark comets are covered in a thin, insulating layer of dust or rock that hides pockets of internal ice. Unlike traditional comets, whose surface ices vaporize and create visible jets, dark comets might only release gas through microscopic cracks or through processes too subtle to generate detectable dust. This would create tiny, nearly invisible jets powerful enough to produce non-gravitational acceleration, but not enough to form traditional cometary tails. Another possibility is that these objects are composed of materials with unusual thermal properties, causing them to absorb heat unevenly and release energy in ways that mimic propulsion. There is even speculation that certain dark comets might represent fragments of once larger bodies that broke apart under the stresses of solar heating, leaving behind smaller, more volatile cores wrapped in rocky debris. One of the most profound scientific questions connected to dark comets concerns the origin of Earth's water. For decades, researchers have debated whether the water in Earth's oceans came primarily from comets, asteroids, or some combination of the two. Comets carry substantial amounts of water ice, but many have chemical signatures that do not match Earth's water. Asteroids, meanwhile, contain minerals that can release water when heated, but may not hold enough to explain the volume present on Earth. Dark comets, if they contain hidden reservoirs of ice, may represent a missing piece in this puzzle. Their hybrid nature suggests they could be icy objects that migrated inward early in solar system history, carrying water deep into the inner planetary region. If so, studying them up close could offer clues about the delivery mechanisms that shaped Earth's environment billions of years ago. At the same time, dark comets may represent subtle hazards that current planetary defense strategies are not designed to detect. Traditional asteroid tracking systems rely on predictable gravitational motion, with minor variations accounted for using established models. But if a population of small, stealthy objects is drifting unpredictably due to hidden outgassing or other unknown processes, then their orbits may diverge from predicted paths over time. A small shift of even a few hundred kilometers could eventually place one of these objects on a collision course with Earth without early warning. To make matters more complicated, their dark, inactive surfaces make them difficult to detect using optical telescopes. The idea that a category of objects may be drifting through the inner solar system with low visibility and unpredictable motion has sparked renewed interest among planetary defense experts. Fortunately, humanity now has an unexpected opportunity to study one of these mysterious objects up close. A Japanese spacecraft, originally designed for another mission, is currently racing toward a target that has since been identified as a potential dark comet. By pure coincidence, the spacecraft's planned trajectory aligns with one of these enigmatic bodies, giving scientists a chance to observe it directly when the probe reaches it in 2031. This encounter could reveal the composition, surface features, internal structure, and possible outgassing behavior of a dark comet for the first time. The data collected may finally answer whether these objects truly contain hidden ice, whether they are remnants of ancient cometary bodies, or whether they represent something entirely new. Whatever the result, the mission promises to deepen our understanding of the solar system and provide insights into the origins of water, the evolution of small bodies, and the potential risks posed by stealthy near-Earth objects. With each discovery, dark comets challenge our long-held assumptions about the neat categories we use to classify celestial bodies. They remind us that the solar system is far more dynamic and diverse than we once believed. They may help explain Earth's past, influence our plans for protecting the planet, and reveal new processes that shape the motion of objects through space. For now, there remain some of the most intriguing mysteries orbiting our sun, silent, shadowy travelers whose secrets are only beginning to come to light.